This is one of my latest demos. It's a moving space versus another moving space. Right now this is configured that the space around the observer is moving at 0.9%, 0.9 times the speed of light, 90% of the speed of light. So the distance in front, the moving object, moving space, would see the light from the front of their ship in only about half a second, while they see the light from the tail of the ship at 10 seconds. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And about one half forward. So in the frame of themselves, because the light takes longer to get to them, or a shorter time to get to them, they see their ship contracted or expanded. But a stationary observer is only, when they're immediately passing them, this is seeing 1 second in the past. At t equals 0, the time is, the color is supposed to be green, and 1 second before green is red. So if this was passing a stationary object after 1 second, it would see simultaneous events from all sides. But if it's before, then it sees one side 2 seconds before the other side. So in the case of a stationary observer, it's always 2 seconds, even when it's passed, that is being observed. So this is always 2 light seconds long, and is not dilated or contracted because the observer is moving fast past it. But, pardon me, from 0, this is going to emit a green signal, and at 0.5 seconds, this green edge is seen from that object, but the other object is still a second in the past. It takes nearly 10 seconds before the left edge gets to be the green edge. So there's a, after 1/2 second, you see one side of the ship, and then 10 seconds later, really 9.5 seconds later, you see the left-hand side of the ship at the same time. That's the same signal. So a flash of green would be seen first here on the right, and then here from the left side. But again, this is always 2 seconds across. The object itself sees 1/2 second ahead of itself, but it sees 10 seconds into the past for itself. If the moving observer knows how big their ship is, they can deduce that this light took longer to cross that distance. But because the distance is longer, then obviously that the light took 10 seconds to get there makes complete sense. So in one sense, this looks kind of like the speed of light to this observer, because it's coming across a longer distance or a shorter distance. But in reality, his ship is still just 1 second square. So he knows that this is not 1 second away. There's 10 seconds of color through here. 1, 2, 3, 4, 5, 6, 7, 8, 9. I guess maybe this first one is 10. It's kind of into a half color. But a moving observer, this is what the observable appears like to the observer after it's passed. It's contracted entirely. And it's only 1.5 light seconds long or something. Green to blue. And this is much longer than 10 seconds. Well, it's 20 seconds because it's now 2 light seconds wide. So I have to pass a little bit. And then 1 light second is 10 seconds. And this is just appears to be shorter. I don't know what else to say about this. These various controls, the direction controls the direction of this observer, or the direction of the observable, if it's moving at a speed and showing the observer. Oh, that's faster. So now they're both going 0.9. And they cross each other and passes by, and all is well. This can be, say it this way. Or rather, we can go this way. So this is moving up while this is moving to the right. And then it's kind of interesting, although the ship is moving away at this direction from your observer, literally, this is the literal position of the ship. This is the image of the ship that you're seeing. I guess the other point was if you're towards the back of the ship, you'll see the back of the ship before the front of the ship. So it's not that what's behind you is always expanded and that you'll always see the front ahead of the back. I suppose that's about all I got.